Let ABC be a triangle with side lengths 13, 14, and 15. Denote by W its incircle. A line L tangent to W intersects AB and AC at X and Y respectively. Suppose XY equals 5. Compute the difference of the lengths of AX and AY. I've drawn triangle ABC here, which has side lengths 13, 14, and 15, as well as a line L that intersects AB and AC at X and Y, where XY is equal to 5. XY is also tangent to triangle ABC's incircle, known as W. And we want to find the difference between the lengths AX and AY. Using this info, we can label AX as the variable X and AY as the variable little y. Then XB is going to equal 13 minus X, and YC is going to equal 15 minus Y, and BC is equal to 14. Using this info, note that we have all four side lengths of quadrilateral BXYC, and we also know that quadrilateral BXYC has an incircle, and that is just W. So we can break out the Pitot theorem on quadrilateral BXYC because the quadrilateral has an incircle. The Pitot theorem states that opposite sides' sums have equal lengths whenever the quadrilateral has a circle that can be inscribed inside it. Using that for this quadrilateral BXYC, we get 5 plus 14 equals 13 minus X plus 15 minus Y. And that's just 19 for the left is equal to 28 minus X plus Y for the right side. And that gives us X plus Y equals 9. We can learn even more information about X and Y by expressing the radius of W in two different ways. The first one is via the incircle area formula. So recall that K equals RS. The area of the triangle ABC is equal to its radius of W times the semi-perimeter of triangle ABC. Here, it is well known that a 13, 14, 15 triangle can be split up into a 5, 12, 13 and a 9, 12, 15 by its altitude, which I've drawn in red. Thus, its area is equal to 5 times 12 over 2 plus 9 times 12 over 2, and that's just 14 times 12 over 2, so 14 times 6 is 84. That's equal to R times its semi-perimeter, which is just 13 plus 14 plus 15 over 2. That's 14 times 3 over 2, or 21. R is equal to 84 over 21, which is 4. We could also get this radius in a different way from using the perspective of triangle AXY. From that perspective, W is simply the AX circle. The AX circle has radius K over S minus A. You should know this formula if you've read EGMO. And from the perspective of triangle AXY, that's equal to the area of triangle AXY. K denotes the area of a triangle, divided by S minus A, which is simply the semi-perimeter of AXY minus the length XY. We can rewrite this as the area of AXY, which is unknown, divided by the semi-perimeter of AXY. We know the perimeter of AXY is X plus Y plus 5, and we recall that X plus Y is 9 from here, so X plus Y plus 5 is 14, and half of that is 7. 7 minus XY is 5 from the problem statement, so 7 minus 5 is 2. That's equal to 4. So the area of triangle AXY is 8. And I know it's 4 because that's simply the radius of the AX circle, or the radius of W, which we found was 4 from earlier. So now we found that the area of triangle AXY is equal to 8. And we can also express that in a different way. We can use the law of sines area formula for X and Y. So we have xy times 1/2 sine A is equal to 8 by the law of sines area formula on triangle AXY. So we can write xy times sine A equals 16. We can compute sine A from the area of triangle ABC. Recall that the area of triangle ABC was 84. So using AB and AC as our side lengths, we have 13 times 15 times 1/2 sine A. This is another way to get the area of triangle ABC is equal to 84. So we have sine A is just 84 times 2 over 13 times 15, which is equal to 168 over 195, and that's equal to 56 over 65. So plugging that in to xy times sine A is 16. That means that xy is 16 divided by this 56 over 65. We have xy equals 16 times 65 over 56, which is 1040 over 56, or 130 over 7. The problem wants us to compute x minus y because it says compute the difference between ax and ay, and that's fairly simple here using algebraic manipulation, given x plus y and xy. So recall that x minus y squared equals x plus y squared minus 4xy. And in this case, that's equal to 9 squared, 81, minus 4xy is 520 over 7. So we have 567 over 7 minus 520 over 7, which is 47 over 7. Taking the square root, we get x minus y is equal to the square root of 47 over 7. Rewriting this, we see that it's equal to the square root of 329 over 7, and that will be our answer to this CMIMC problem 7. Thank you for watching, and please follow my channel, MOP 2024, if you would like to see more videos.